So it comes about that in our physics, we often making use of trigonometric functions. We often making use of sine and cos. And what we're interested to do now is to know how to differentiate trigonometric functions. And the way we're going to approach it is in a very intuitive way, and we're going to figure out what the derivative should be. The first function we're going to look at is sine of theta. So what I've drawn is I've drawn a graph of sine of theta as shown, and what we're interested to calculate or find out is what is the derivative of sine of theta. So what is d theta of sine of theta? Well, if we look at that, then on an intuitive level we know that a derivative is a gradient at every point. And you can note that, of course, for our function sine of theta, the gradient is going to be changing. If we take a look at 0, at theta equals to 0, so this point here, what is the gradient at that point? Well, to find the gradient, it's a line that's a tangent to that point, and a tangent to sine of theta at 0 is going to be 1. So that means that at theta equals to 0, sine of theta has a gradient of 1. So in the graph below, we're going to plot the derivative. Then what happens is as we move along this point here, the gradient decreases until we get to the point where theta equals 90 degrees. And at this point, the gradient, it decreases to 0. A tangent to the line would look like that. So that means at 90 degrees, our gradient is going to be 0. If we take a look at the gradient, it changes, and then it reaches at 180 degrees. It's now minus 1. 180 degrees, the gradient is minus 1. Similarly, when we get to 270 degrees, you can see at 270 the gradient is going to be 0 again. So 270, the gradient is going to be 0. Whereas when we get back to 360, it's going to be positive 1. The gradient's pointing in a positive direction. So at 360, it's going to be positive 1. If we did this for each of the individual points, so each of the points in between the ones we've looked at, then we would find that what we actually get is we actually get a graph that looks like this. Connecting the dots goes to 0. At 180, it's minus 1. And it goes like this, goes like that, right? Let me redraw that nicely in color now that I've put it in. So our gradient, it goes like this. So what we've shown is that the gradient of sine of theta in fact looks like this. And if you take a look at this curve, you in fact recognize it. You find that this curve shown in purple is exactly the curve of cos theta. So then this brings us to our first important point, or our first important observation, that the derivative of sine theta with respect to theta is equal to cos theta. And this is something that you should remember and always have at your fingertips. The next function we may be interested in differentiating is cos of theta. So we may be interested to know what is the derivative with respect to theta of cos theta. So let's go about that in exactly the same way as we did for the previous function. We can take a look at the gradient at each point. Over here, the gradient is going to be 0 because the graph is flat. So this is going to be our first point on the gradient curve. When we move to 90 degrees, you can see the line is pointing downwards. The slope is negative, right? And the value is going to be minus 1. So over here, it's going to be minus 1 at 90 degrees. As we get to 180 degrees, here you can see the gradient is flat at 180 degrees. It's a turning point. So at 180 degrees, the gradient is flat. When we get to 270, we can note that our gradient is positive 1 at 270. So at 270, it's going to be positive 1. At 360 degrees, it's going to be 0 again. It's going to be 0 here. So what we do then, as before, is, you know, we connect up all these points, and what we get is a graph that looks like this. Looks like this, right? Let me just put this guy in color again. So this graph shown in pink is the derivative of our original graph cos theta. And if you look at this graph, it looks a lot like sine theta, except sine theta starts by heading off upwards and then going down. So this isn't sine theta, but this is in fact minus sine of theta. This graph is minus sine of theta. So we have the important results then that the derivative of cos of theta is equal to minus sine of theta. The next important rule we need to know for differentiating trig functions is something called the chain rule. It's best illustrated by means of an example. So the example is, we're given a function, x as a function of t is equal to sine of 3t plus 6. We asked to calculate what the derivative of this with respect to t is. So the way we do this is, according to what we saw before, we've seen that sine will become cos. So this is going to be cos of 3t plus 6. Now here's where the magic comes in. We need to apply the chain rule. So the chain rule tells us that we aren't finished with the solution yet. What we need to do is multiply by the derivative of what's inside the bracket. I'll say we need to multiply this by the derivative of what's inside the bracket. So we need to multiply by the derivative of what's inside the bracket. Right? And if we take the derivative of what's inside the bracket, we just differentiate this normally, then we can see that this is going to leave us with 3. So this is going to be 3 cos of 3t plus 6. That's going to be our final solution. Let's take a look at another example. So in this second example of us applying the chain rule, we asked to calculate, or we given x as a function of t is 8 cos of this, and we asked to calculate what is dx dt. So what is the first derivative with respect to t? Well, when we produce the solution, we should just treat the 8 as a constant, and then we should note that cos becomes minus sine. So what we're going to have is cos will become minus sine. So this will be minus sine of 3t squared plus 7t plus 2. That's fine. Now what we need to do is apply the chain rule. So the chain rule says take the derivative of what's inside the bracket. So that means take the derivative, take d dt of 3t squared plus 7t plus 2. To finish the answer, we need to write it in its final form. So this is going to be minus 8. We're going to have minus 8. If I evaluate, take this derivative, this is going to be 6t plus 7. So it's going to be 8 times 6t plus 7. And then I still have my sine of 3t squared. As shown, right? The final step is just to simplify. This will be is equal to minus 48 and then this then is our solution. Here's one final example for us to practice our chain rule for differentiating trig functions. We're given this function here, and this time we asked to calculate the second derivative with respect to t. Well, the way we do that is, of course, first by calculating the first derivative. So dx dt, this will be equal to, if we differentiate sine, it just becomes cos. So we'll have cos of 3t plus 6. We need to remember, of course, to apply the chain rule. So this says we need to differentiate whatever's inside the bracket. So this will be d dt of 3t plus 6. When we differentiate 3t plus 6, we can see that we left with just a 3. So this will be 3 cos. So this is the first derivative with respect to t. But in fact, we asked to calculate the second derivative. So we need to take the new, we need to take this function and differentiate it again. So it means d squared x dt squared is equal to, what I'm going to do is write the 3. Now when we differentiate cos, it becomes minus sine. So I'm going to put the minus there. Of course, I need to apply the chain rule, and the chain rule tells me to differentiate what's inside here. So for this case, we have what's inside is 3t plus 6. So when I evaluate this further, I can see that differentiating this is going to give another factor of 3. So this is going to be minus 3 times 3 and of course 3 times 3 is just a minus 9. So then we've seen 3 important points for differentiating trigonometric functions. The first thing is that when we differentiate sine, it becomes cos. When we differentiate cos, it becomes minus sine. And the third point is that we need to apply the chain rule.